So in the first series that we've done here about Passive House, we introduced general principles and the concepts. And in this program, we're going to talk in a bit more detail about the building fabric. We're going to look especially at insulation and at airtightness. And these are the two main methods that we can use to reduce heat loss from the building. Now, you have to remember the Passive House standard was defined 20 years ago, that's 2 decades ago. And the standards that were defined back then for Passive House in terms of insulation and airtightness still greatly exceed current building norms. So to give you an example, the current EU value required by Irish building regulations is around 0.27 watts per metre Kelvin, whereas we'll be seeing in this series walls which have a U value of 0.10. That's 2.5 times better insulation standard. And in terms of airtightness, the current building regulations require an airtightness of about 10 air changes per hour, whereas the Passive House standard requires an airtightness of 0.6 air changes per hour. So that's what we'll be covering in this next series. So we know the Passive House standard requires an incredible amount of insulation, and we have certain target U values. So for example, somewhere between 0.10 and 0.15 is what we need in the walls, in the roof and in the floor. But the Passive House Institute don't give us any direction, for example, on what materials we should use. So we're free to use whatever materials we like to insulate our house. And there are a lot of materials on the marketplace now, and they differ in terms of cost, they differ in terms of where they can be used, they differ in terms of their embodied energy, how they're manufactured and so forth. So there's a lot of decisions that we have to think about before we actually choose our insulation material. And we have just a few insulation products here. The one at the bottom here is polystyrene. It's one that we're very familiar with. It has a lambda value of around 0.035 and is used very extensively and very commonly in a lot of Passive House projects. A more natural material, you might say, is this sheep's wool insulation, and that has also got very good insulation qualities, a lambda value of around 0.04. And obviously you can see by its structure, it's very good for use in walls and for roofs where it can fill all those cavities. Quite a new material on the market is this vacuum insulation. It's like a space age insulation, and it has an incredible lambda value of 0.0022. And so you get incredible amount of insulation properties for something that's as thin as your little finger. Sticking with the theme of insulation and airtightness, one of the first decisions you have to make when you want to decide about your Passive House is, am I going to build it in timber frame? Am I going to build it in masonry? Am I going to build it in steel or whatever? And we have a fantastic example here of really excellent timber frame construction. So let's have a look at that in a bit more detail. One of the first things you'll appreciate from this is the amount of insulation that there is in this structure. We're talking about 400 millimeters approximately of insulation, which is probably double what you would get, or perhaps even more than double what you would get in a standard house. Looking at the cross section of the wall then, this part here is the main structural element of the house, so that's what keeps the house standing up. And you can see in this case it's filled completely with cellulose insulation, which is a very natural material and is blown in, so all the cavities are filled. On the outside of this then we have about 100 millimeters of fibre-based insulation, and you can see that running down along the entire structure, and you just can get the impression that this insulation here is preventing any cold bridging through this timber stud-work. And the last and third layer of insulation, which is very important, is on the inside of the house, and this is what we call a service cavity, and this allows us to create an airtight layer here, and this is our service cavity where we can pull pipes, wires, any sort of conduits without compromising the airtightness.
Now let's visit the construction of a private dwelling to see these principles applied. This project, being built to Passive House standard, utilises the materials we have just seen to achieve the required insulation values.
My name is Niall Cross and I'm engineer with Ecological Building Systems. I'm here today to provide site guidance to the clients on this project, which is aiming for passive house approval. Ecological Building Systems are supplying thermohemp natural insulation, cellulose insulation, as well as the external render and wood fibre board Gutex Thermowall. On this passive house, the wall build-up will be as follows. There will be a gypsum plasterboard on the inside, then we'll have a service zone with 80mm of thermohemp. Then we'll have an 18mm OSB board. This will act as the airtightness and vapour control layer, which will be taped and sealed with the ProClima system. Then we have a 241mm thick I-beam stud, which will be filled with blown cellulose paper insulation. Then on the outside of these walls, it will be insulated with a combination of either an 80mm thermowall board, which will be plastered. This is a Gutex wood fibre board, or alternatively an 80mm Gutex Ultratherm board with a ventilated cavity and an external covering. Hemp insulation is manufactured from hemp, the world's oldest cultivated plant. It has a very high thermal value, it's very lightweight, easy to install, primarily installed as a mat. It also is non-allergenic and assists in improving indoor air quality as it doesn't contain any harmful VOCs. Cellulose is made from recycled paper. It's an environmentally friendly material. It's non-allergenic, has a high fire resistance, has a very high acoustic value and is an excellent thermal insulation. Gutex, primarily manufactured from wood, a natural material, offers outstanding acoustic performance, has an exceptionally high thermal mass, offers outstanding thermal resistance as well, is a very vapour open breathable material, also features a very high mechanical strength to prevent stress on the external plaster and lends itself to a very healthy indoor living climate.
Having looked at an exemplar timber frame construction, it's now interesting to look at something which is completely different, and in this case we have a mock-up of a masonry project or a concrete built project which is insulated externally with polystyrene. Roughly about half of passive houses built in Europe at the moment are built with this type of construction, so I think it's important to look at it too. Again, the first thing that will impress you, I suppose, is the thickness of polystyrene that we have here. Normally you might have 70mm, but in this case we have 315mm of insulation. And again, we're looking to create a U value of around 0.10. One of the main advantages of using polystyrene like this is you'll notice that it's placed external to the masonry leaf, so that the house is completely thermal bridge free. And even the windowsill is made of polystyrene in this case, so there's absolutely no cold bridging at all, and therefore that reduces the heat loss very significantly and makes it a lot easier to achieve the passive house standard. And don't worry about robustness. There are very good proprietary systems now which can be used to plaster these walls. You can see they have special angle beads along the walls here, for example, and along the windowsill, and everything is very robust. So when we're using this external insulation system, we need to be very careful wherever we've got a joint or a junction, and there's a very typical detail, for example, like we've got here, where you can see here there's extra reinforcing here with the mesh at this junction, so that we won't get any hairline cracks or expansion cracks over time. So these kind of details are very important when you're using an external insulation system. Another very important topic in terms of passive house is airtightness, or we might use a similar term, draft proofing. In terms of airtightness, the standard required for passive house is about 10 to 20 times what's required by current building regulations standard. So it's very impressive. So you might think, well, why build our houses to an airtight standard? Well, the first obvious benefit is that it cuts out any drafts. So all the junctions around windows, any floor to wall junctions and so forth are completely draft free. So we don't have any uncontrolled cold air infiltration. But there's another very important point we have to consider in relation to timber frame construction. And These membranes, these airtight membranes, also act as vapor barriers so that we don't have any risk of high humidity in the house migrating into the timber structure and perhaps later down the road causing problems in terms of decay and rot. So by building an airtight house, we have very high levels of comfort, and we also have a secure structural basis going on for decades and decades. So having looked at the principles of passive house airtightness, let's examine in a bit more detail how this is achieved on site. We have barriers here which define or are laid underneath the attic insulation here. Here we have another barrier which lines the wall insulation, and it's very important that the junction between these barriers is taped, and not with ordinary duct tape or something like that, but with special airtightness tape which has been age tested, because you want to make sure that this building is going to be airtight not just for 5 years or 10 years, but in fact for decades. So we use this special proprietary tape here, and then we also want to make sure we get a very good connection between the window frame and the main structure. And again, you can't trust plaster to achieve that level of airtightness, because over time the plaster will shrink and pull away from the timber frame and you'll have cold air infiltration. So again, we use a special proprietary taping system to achieve this very high level of airtightness. Another problem we can have in terms of airtightness is where we're putting services through the building envelope. So whether that's waste pipes or wires or whatever. And you can see here again that the manufacturers of these products have come up with very high quality proprietary products. So here we have a cable, let's say it's for a light switch or for a socket or something like that, and it would puncture the airtight membrane. So we've got a special rubber diaphragm on this which keeps this airtight and prevents any cold air coming in, but it also prevents any humid air getting into the timber frame structure, which could be a problem down the line. Having looked at the airtightness membrane on the inside of the building, let's imagine now we're on the outside of the house, and now we're thinking about wind tightness as opposed to air tightness. And wind tightness is very important in climates like Ireland and the UK, because we have quite high wind speeds. And if you have a lot of cold air blowing across the insulation, it can actually reduce the insulation value of that. So here we use a special membrane, and when properly fitted like this, it produces a very nice wind tight layer, and therefore greatly reduces the heat demand of the project.